Hi, once again, hello. Now we're going to measure a drop across a fuse. And we're going to see if there's current across it. Now, I'm going to use this tool, a tweezer tool. And this goes to, as you can see, common and volts. Before we ever do anything, we always have to short the pins together, make sure that the probes are good. So as you can see, when I short the probes together, the tweezer's over here. I get close to 0 ohms, 0.4. That's when they are together. Now, so that means the probes are good. Now we're ready to start. We're going to take this and we're going to put the meter on volts. Volts DC. Okay? Volts DC. As you can see, DC. Now, the left turn signal is on. Now you know the left turn signal goes on and off, on and off, on and off. That means I expect some millivolts. I'm going to have something in millivolts go on and off. If I zero this again, we'll come down to very close to 0 millivolts. Okay, that's noise. See, I'm closing the tweezers. When I open them, I'm getting noise. The left turn signal is right here. Right here, left turn signal. That's the fuse we're going to go. Come over here, there's two right turn signal, left turn signal. I'm going to put my tweezers on this, as such. Watch the meter fluctuate up and down. You see the millivolts? This is in millivolts. That left turn signal is going on and off, on and off, on and off. That's the voltage drop across that fuse. See how high it goes? 11 millivolts, 12 millivolts, goes down to maybe 4 millivolts. So what I'm trying to represent to you is there's a voltage drop across that fuse. Let me go to another one, the right turn, which doesn't have it. See the other one? Go to this one. This one is like fluctuating like the other one. The correct one, this one, you see it fluctuating. And that's the turn signal on the left turn signal going up, on and off, on and off, on and off. The best meter to have for this is a minimum and maximum, where you can see it go from the lowest measurement to the highest measurement. And always remember, there's noise. Let's try to zero it and see if it helps. See, that's the problem with the voltage. There's noise all around. Again, the only thing you can do is to make sure that you come to 0 as close as you can. Time. When you zero it. So anyway, the point that I wanted to make was that the voltage drop across the fuse can be measured in millivolts because it's so small. I use that as an example. So hopefully you'll understand going the voltage drop. And these are the best type for it. These are called the tweezer types. But these fit on the small ones. For the big ones, they won't fit. But these are like for this purpose, to measure the millivolts across it. That means there's a current going through it. Why is there current going through it? Because the left turn signal is on and off, on and off, on and off. If you go to another one, pick any one that you want. See? No current, no millivolts across it. There's no millivolts because there's no current going through it. That's how you know. I take it away, I get noise. There's noise from the motors, from the fans, everything going on. This meter is receiving that noise. That's why you see millivolts. So I hope this helped, and please go to my channel, Joe Electronic Schematic for Auto. You'll see much more. Again, the relay, to measure the relay, especially the fuel pump relay, you do it in circuit. Listening to it, if it's on and off in a run position, is of no value. You have to do measurements.